Okay, right. So for the second part, we are going to do the speech recognition. Okay, so for the robot able to interact with you, not just the robot able to say something, but it also need to understand or at least need to able to hear what you say so that you can have a conversation, right? Okay, so the second part, speech recognition. Similarly, I'm going to show you the online and also the offline version. Okay, the online way and also the offline way, right? So yeah, I'm going to skip this. So this is the second part. Okay, for speech recognition, it is actually a very big topic. Okay, many technology, many effort, many projects have been working on improving or develop a very good speech recognition technology. And also sometimes it is called ASR, automatic speech recognition, ASR. Okay, so it is a process to extract speech contents from human voice or human speech. Okay, so it is a reverse of what we have done just now in the speech synthesis. So just now is text to speech. Now is speech back to text, right? So you want to extract what is the content that is spoken by someone. Okay, that will make the robot able to understand, or not really understand, but to get the text content that you just say, right? And also, it is actually a very long research and development. For example, like Windows, if I'm not mistaken, I think Windows 98 or even earlier, we already have speech voice command function. So which means speech recognition technology have appeared like very long time. And the technology have been improved until today. We can actually see a lot of application. For example, speech recognition is available even on your smartphone, that you can do your inquiry. For example, you can talk to, for example, if you have an Apple iPhone, you got a Series. Okay, you got Android phone, you also have some virtual agent that you can converse. Okay, you can ask question with your to your phone. For example, what is the time now? Can you play me a song? And then we also have home voice assistant, for example, Google Home, Amazon Echo, and a lot. I mean, you can find a lot, and you can find a lot of speech recognition technology being used in many applications, in many appliances. Okay, so now you can actually like talk to many things, and they can respond to you without you putting any, for example, like key in any command or press a button or anything. You can do everything by voice. Okay, so yeah, today speech recognition is everywhere, and also because it is so a lot of effort and also development have been done, we actually have many ways to do speech recognition. Okay, so this photo that I show you is not the only way and it's not the standard way. Okay, it is just an example that I taken from one of the conference to show you some basic idea. Okay, so it starts from voice signal, which is like a wave. You can see the voice signal. Then once it captured by your microphone, then it go through your sound card, then it become a signal, right? So it convert from a wave, sound wave into electronic signal, right? So it become a signal. Then from the signal, you can apply all your signal processing technique. For example, the first thing you do is feature extraction. So feature extraction is from a series of signal, you try to identify certain pattern, certain standard pattern that you can find. Okay, something that appear frequently, or something that you can extract. Okay, it's a features. Okay, so if you study signal processing, you understand this process. Then from the features extraction, then you either go for training or you go for recognition. So in your training phase, which means you try to extract the features, and then you have your you build your template library. So which means you try to train your system so that if you have these features, it means something. Okay, it means certain pronunciation, for example, certain words and so on. Okay, so that is in your training phase. But when you are in your recognition phase, you are going to compare your features. So for example, you already have a very nice complete template library. So you have the library that if you see this wavefile or waveform, then it belongs to this word and so on. So when you have this, then you do the pattern matching to match with the features that you identify from your wavefile. Then you can start to recognize, for example, like how similar between these features to your pattern from your library. Okay, so you can compare, then you can tell the user like, okay, I hear something very similar to what I have or what I know in the library. So I guess the meaning of this is this, or the word spoken is this, and so on. So this is the process of speech recognition. And you can see there's a decision there, which means you are going to tell the system your threshold. For example, like if the pattern matching result or the confidence level is higher than 50%, then okay, yes, it is recognized as this word and so on, right? So it is an estimation, okay? Recognition is an estimation. It might not be perfect because everyone speaks differently. Even the same text spoken by, like, for example, 10 person, it might have 10 different wavefile, right? And also even for one person, different timing, different condition, when you say the same sentence, you might create slightly different wavefile. Okay, but everyone have their own, how to say, voice profile. So you can use that like with a lot of very advanced signal processing technique to actually do the identification or recognition. Okay, so these are all the research and development under this speech recognition. That's why a lot of things can be done in speech recognition. Okay, right. So this is the background of speech recognition. But today, we're not going to do all this thing. For example, like it can be very complicated. For example, like today, we have deep learning based technique. So they use deep learning based technique to do speech recognition. They use a lot of big data, a lot of data to train the system so that it can recognize many people, different voice, and so on. So a lot of things can be done. But today, we are going to show you something very, very basic. Okay, something very, very basic. Right. So for speech recognition, offline. Okay, so we always start with the offline. So for offline, we are using this CMU Spin. Okay, so CMU Spin is a group in CMU, a computer science department that work on speech technology. Right. So you can go to the website and look at. They have a very nice tutorial and so on to explain their tools and so on. Okay, and within this CMU Spin, we are using a module called Pocket Spin. Right. The Pocket Spin is the module in CMU Spin that we use for our application here. And down there, you can see the ROS Pocket Spin. So this is the ROS package that wrap the spin or the Pocket Spin function so that we can use it in ROS, right? And then over here, the example that I'm going to show you after this is using the language model of US English, right? So we use this model. So the pronunciation or the recognition is done by comparing the library that built from the voices from English from the US, okay, the American way of speaking English. So sometimes, because I'm not native English speaker, so sometimes my pronunciation might be not so accurate or standard to be recognized by this model as well, right? But that is what the challenge when we do speech recognition. So it's not just about how accurate we speak, but sometimes different people, we have different slang when we speak English, the way we speak English, and so on. That will affect, and those are the criteria, and also those are the consideration that you need to put in speech recognition. Okay, so basically this is the system, right? So if you want to know how to set up this, because this Pocket Spin and ROS Spin and so on, the setting up is a bit complicated, so I'm not going to explain here, but if you are interested, feel free to contact us. We will show you some additional material how to do that, right? Okay, right. So just assume that you already installed Pocket Spin and ROS Pocket Spin, right? So now let me show you example. Okay, so in Pocket Speak, there are actually many ways to do the recognition, and inside they got two main ways to do the recognition. One is the KWS, and another one is LM. And we usually will recommend you to use LM for our application because in RoboCup, sometimes we need to create the language library. So you need to remember when we are doing offline, which means the library that we do the pattern matching just now, it is actually you need to do the pattern matching on board. So which means we need a lot of calculation, we need a lot of computation power in order to process everything offline. Okay, so we cannot have something that very large database. So which means it is not easy for us to develop a robot that can speak anything or robot that can understand anything, right? It's because like if you want to do that, you need very big database, which is it will be not enough computing power if you just have a normal PC or just a very small computing power. So if you want very open-ended or open a very big database for recognition, then you might need to consider to use the online version, because like when you do the online, for example, we use the Google Speech API that to do the speech recognition, it got a big farm of server to help you to do the computational. Then you can do that, right? But for offline, usually we have a dedicated amount of language model or library in order for you to do the recognition. Okay, so but that is the learning part. Okay, why I want you to learn the offline and online, because both have advantage and disadvantage, pro and con by itself. The offline one, you don't have very big database, you have very small one, but it is very good for dedicated recognition, which means you can ask the robot to keep on listening to some keyword, some comment. For example, hello Google. That is what we call the wake up phrase. The wake up phrase, if you want to save the resources, we always do the offline way. Then after that, we pass to the online way to do the open-ended. Because always you use the hello Google to turn on your Google Home, then you say your question. Yeah, so that is how the strategy to balance between local computational power and also online computational power. Because if you use online mode all the time, then you are going to use a lot of resources to access the server, and your latency and all those problems is actually a problem for online method, right? So, and when your robot is not connected to the internet, basically it cannot do anything. So we don't want that. So we need to balance between offline and online method. Right, so I'm going to show you this KWS. Then after that, we have the LM, which is a two mode in speech recognition. Right, so I'll show you, and these are all, you can find the file within your system after you have installed. Okay, so now let me So now let me switch to my terminal. Okay, switch to my terminal. Okay, over here. Okay, right. So from here, I'm going to minimize this. Oh, sorry. I don't want this. Okay, right. So go to speech recognition. Okay, I'm going to close this. Okay, stop this. Right, so for the first one, we are going to run this one. Okay, so first is let me show you the dictionary file. So for offline mode, you need certain, okay, this one is running is good. You need certain how to say, dictionary file and some database that I say just now. So you need to tell the system what kind of word you want the system to recognize. Okay, so now let me go to raw CD we go to Pocket Spin. Right, then we CD to demo. Okay, right, so we have all this. I'm going to nano voice cmd.dic. Okay, so this DIC is the dictionary file. Okay, in Pocket Spin, this is the dictionary file. So the dictionary file look like this. So only a few words that we are going to recognize, which is like back, forward, full, half, left, move, right, speech, and stop. And over here, you can see this is the pronunciation, something very similar like when we find the dictionary pronunciation. And I realized this is very American English because like when stop, I will say stop. But the American way is stop. So you can see there's no O here, but A, double A, stop. So this is the American way of pronounce stop. So that's why when I say stop, sometimes the recognition rate is not good. Okay, but anyway, this is the DIC file, how the DIC file look like. So I'm going to use this for my example after this. Okay, right. So you know this. So now I want to run this example. I'm going to copy this. Okay, so this is one whole big chunk. I'm going to explain this. Paste this. Right. Okay, so this one, why this command so long? Okay, so let me explain. So I'm actually running ROS launch, which is a launch file, and then the package is Pocket Spin, which is the Pocket Spin that we developed, and kws.launch. Okay, so it's the KWS example. And then we need to specify two arguments here, which is to specify two files that we need to tell. Okay, so first is the dictionary file. So first, where's the dictionary file? So I need to tell the system my username is RFA for all here. And inside my workspace, I can find my Pocket Spin, and then inside there got this voice underscore cmd.dic, which is the file that I just showed you just now. Then the second file is this keyword spotting list. Okay, so over here I need to change this to a username, and then this KWS list. Right. So, but I didn't show you this KWS list, right? Let me show you what is this list. Cross get spin demo. Okay. Okay. So let me show you this one, KWS list. So this KWS, so KWS is a keyword spotting. So you need to specify. This is what we call the threshold level, right? Right, over here that we put in. So this is the format by the KWS that we need to key in this. And that's why we seldom use this, because it's not easy to determine this to generate this list. But yeah, just to show you the example, so it is very similar keyword that we put in. So this is the library or the template, sorry, the database, okay, that we set back, forward, full speed, half, left, move, right, stop. Okay, right. So it's very similar to the dictionary file just now, the same list. Okay, so with this list, to point these two files to this kws.launch in order to work. Okay, so I already like put in, there's two arguments, then I run this. Okay, so this one, okay, yeah, it's running. So I try to say stop. Yeah, it's over there. Right. Yeah, it's over there. Okay, so maybe it's not so obvious. Let me print out the topic. ROS topic echo, and then what is that again? KWS data. Yeah. Back. Right. Stop. Stop. Yeah, not so good. Okay, but well, yeah, you got the idea. Okay, so single word is not easy to recognize. Okay, but anyway, so this is just to show you the example. Okay, And with this output, I can actually show you to control a robot, for example. Okay, so my example here, we can actually do this to control a robot. So which mean in the example, we have this. So we have the turtle bot gazebo, and then her turtle world.launch. So I'm going to run the gazebo to show you how I use my speech recognition to control the robot to move. Okay, so we have the robot here. You can see there's a turtle bot. Here that we can, yeah, okay. So now we want to make this smaller. Smaller. Oh yeah, I need to run one more thing. Ross run, I need to run to connect. There's another node to connect between these two. Voice control number of UI. Okay, yeah. So look at this robot. When I say back, can you see the robot is moving? Back, right, right, it's turning right, okay, back and back and back and so on. Yeah, so that is how I control the robot with speech recognition. But the recognition is not so good. Okay, so that's why I don't really recommend you to use this. But I will. But there is advantage why we use this, because for wake up phrase is good to use this. But I will show you another example, which is I think is better one. Okay, right. Okay, I'm going to stop all this. Right. Okay. You kill this. Stop this. Okay, then down there is a source code implementation, which is a talkback that I'm going to show you. I'm not going to show you the talkback because the talkback is the assignment today that I'm going to explain after this. Okay, so we'll come back to talkback after this. So let me show you the second example, which is the LM. Not stopping. This. Okay, right, still running. Good. Okay, second example is this one, but I need to show you this one first. CD. So again, I need to show you the dictionary file. But this within the pocket string, but over here, RoboCup. Okay, so we have a series of this dictionary, and also these are all the database. And inside here, you can see there's a DIC file and also the LM file. These are the file that I want to show you. So let's have a look on the DIC file, which is not very meaningful because we have a long list of words, right? Okay, so this one, it doesn't matter because it just explains how to pronounce every single word. But a more important file is this one, which is what we call the scopus. The topus file is basically just a text file, okay? So we start from this. So using the LM mode, what we need is we need to create a file like this to list down all the possible sentences that you want the robot to recognize. For example, follow me, thank you, good job, bring me the spoon, go to the living room, go to the bedroom, dining room, and so on, and my name is something. So these are all the standard, how to say, frequently used sentences that we use or need to be, the robot need to recognize in at-home competition. Okay, so we have this list. So we create this list, then we supposed to go to this website to compile so that it can give us the LM and also the dictionary file. So the dictionary files look like the dictionary file that I just showed you. The LM file is basically you got all the engram thing, which is, yeah, maybe you don't understand at this point, but it doesn't matter. Important thing is this corpus file. So we create this corpus file, we're supposed to be able to generate, but unfortunately, currently this computer science CMU group homepage is not accessible. Okay, so we are still finding ways to do this for you, but yeah, just learn the basic first. Okay, so with this corpus file, just imagine that we can generate the LM and also the dictionary file. Then with that, I can, okay, so you remember this list, right? So let me create another one. Okay, so let's run the LM command. Okay, so this one, copy this, paste here. Right. Okay, so here again, the same, I need to specify my username. And also over here, the username. So you can see I launch, and then I have the speech module or package. Then I launch the lm.launch. Okay. Then I specified same like KWS, the LM, the dictionary file that I just showed you, and also the LM file. Okay. Then run this. Right. So now again, I need to cross topic echo LM data. So this is the result. Okay, let's try. My name is Michael. My name is Michael. Not very good. Go to the kitchen. Go to the kitchen. Bring me the green tea. Follow me. Yeah, you see, the accuracy is not bad sometimes, but it also have a lot of noise. Like now when I speaking anything, then it come out with some rubbish example, result. Okay, right, but it works, okay? Right, it works. I mean, when I say follow me, yeah, it got the follow me come out, right? So based on just the recognition is not enough. You need to somehow do some filtering to filter out some false detection. Okay, so there are a lot of work you need to do in the offline work. But over here, this example show you it works. Like I can create the list and then I can do this kind of thing. Okay, but of course, the quality of this offline might be not so good. That's why I'm going to show you the next example, which is using the Google speech recognition, right? Okay, so this is the offline one, but it is important to learn the offline one because we want something that to learn, for example, to detect the wake up phrase, okay Google, or things like that, right? So you can use this one for that. And also, if you want to learn the basic, like what is language model, what is database, what is dictionary file, how the speech recognition is done, you want to learn all the basic, you have to start from the offline method, because the online method, you cannot learn anything, okay? Because they have their proprietary technology within the cloud. You cannot have anything. They just give you the API. So you cannot learn the technology behind. That's why you need to learn both offline and online. Okay, but anyway, I show you the online one to see and compare the performance. Okay, so let me close all this. Close this, close this. Oops, sorry. Okay. See, did I mistakenly type something? No, right? Okay, no, okay, right. So now let me show you the next example, which is the Google speech recognition. Okay, to install, you just need to install this one. Okay, speech recognition, very simple. So now first, ROS core. Okay, then ROS run. This is also with our example, Google speech recognition.py. Okay, right. So let me try. Hello, how are you? Good. Very accurate. How are you today? I don't know what else to ask. How may I help you? You see, even my whatever narration or whatever things that I say, it just capture, and the recognition is almost perfect. Right. So this is the technology that run behind, and you can see when we have a very big server behind to help us to do the recognition. Yeah, and a lot of technology involved in. Okay, so yeah, you can see the accuracy is very high. Yeah. Okay. Okay, but if you see the code, it's as simple as this. Let me show you the code. For CD, RC home speech, beep, okay. Then no Google's, oops, sorry. So it's just this few line. You can see over here, I just create a publisher because I want to publish the result to the output result, which is the result topic. Then for this one, because I'm using this speech recognition package in Python or in this PyPI, right? This one, it already like put everything very nicely. So you just need to create this SR, which is a speech recognition. And then if you can see the logic, like, okay, so it start from initialize the node, and then it create a publisher to publish the result to this result. Okay, then so when it's running, so it will try to get the audio from the microphone. So over here, you create the R, and then you get the data from the microphone. So you have the recognizer, you get the data from the microphone, and you record. Okay, so I don't use the listen way, I use the record way, is because if you use the listen way, it will automatically start record and cut. So your environment have to be very quiet, or you have to set the energy level, which is the noise level, which is most of the case you need a lot of adjustment before you can use. So that's why I skip this part, because if you want to use the listen way, which is automatically cut the timing, you need to set, for example, the environmental energy level, the noise level, and so on. Which if you go to this site, okay, you go to this site, there's a documentation link there that you can read a lot how to use this. But as a simple example, I switch this to the record mode so that I just every time when I run, then it start to record, and then after 5 seconds, then it start to recognize, and then it repeat. So just now you see, when I say something, then I say some, when it displays say something, I say something, it recognize, then it go to the next loop and so on. So I will follow the timing of the system. But if you want the system to follow your timing, which means anytime you say something, it start to recognize freely, then you can use the listen mode. But in order for that to be accurate, you need to set the environmental noise level and so on first, okay? Or else the accuracy might be not so good. So I use this way. So it record the audio 5 seconds, and then it put into this recognizer recognize Google, the audio file that it recorded, and then it give you the result. So just this line, basically it just send the audio to Google server, and then Google server make the magic. So we have no idea what happened in between, and it come back with the result, right? So then we print out the result, and then we publish the result. That's all. So you basically have no idea what happened in between, but yeah, you get very nice result. Anyway, okay, so this is the online Google speech recognition, and this is how we use it and publish. Okay, right. So good. I have finished explain and also demonstrate to you this one. Okay, very accurate. You can use it. Okay, so I have done for the offline and online one. So with the remaining time, I'm going to invite once again Jupyter Robot to show you how we can do in Chinese language, right? Dan, are you there?
Yes.
Okay, so let me, okay, yeah, take over. Okay, so now then switch over to Jupyter IO. Sorry, Jupyter OS on robot, I guess, on the robot. So yeah, so now let's see the iFlyTech version. This is also the online one, and you can see the way how it run and everything is very similar. And this is the way we can do the recognition in Chinese.
Right now it's right now it's waiting to be woke up. Now we should.
So this program include the wake up protocol. So we need to say the wake up phrase before it can start to do the recognition.
Yeah. Right now you can say something like, what time is it?
Okay, yeah, the English recognition is very good. How about the Mandarin one?
Okay, we can wake it up again.
Okay.
今天上海的天气怎么样？
Yeah, it's perfect recognition. So very similar like the Google one, the accuracy is very, very high. Yeah, you might want to try one more time.
Okay.
Can you try English and Mandarin together?
Okay. Hello everyone. 我是木星机器人。
Yeah, so you can see it can recognize no matter you mix between English and Mandarin. So this is very high level of recognition, but it can be done magically with the online system. So online service for speech recognition have gone very, very far and very, very powerful. And yeah, if you learn how to use it, you can build very powerful and also interesting conversational robots. Okay, right. Thanks, Dan. Thanks a lot. Okay, so I will go back to my screen. Okay. Okay, so with this, right. Yeah, so this is somehow the last slide before we jump to the assignment. So for speech interaction, we actually have a lot more things to do. For example, just now I want to show you the talkback. So I'm going to show you the talkback after this. So if you combine the speech synthesis and the speech recognition together, then you can start building your chatbot. Okay, whether you're using the offline method or your online method, it doesn't matter. And you can also mix between offline and online so that your offline can take care of your wake up phrase, and then your online one can take up of your question after the wake up phrase. And that is a better strategy, because if you want your chatbot to on like 24 hours, you don't want to send in every second all the audio file to the cloud, because that will use up all your internet resources and so on. So you can use, yeah, then you can build a very sophisticated chatbot or robot that can interact with human. Okay. If you want to see the, okay, so maybe I don't want to switch. I straight away show you the code here, the talk back. So if you want to mix, if you want to put the, if you want to put the synthesis and recognition together, so this is one example. This talkback is one example that I just put the synthesis example and the recognition example together. So over here, but this talkback is basically whatever that it recognizes, okay, whatever that it recognizes, it subscribes. So whatever that it recognizes, it just speak out, right? So this, if you look at this, okay, so this talkback, yeah, right. So whatever that it recognizes, so this is recognized, then it just say out, I heard something. So which means it say back whatever that you tell the robot. Okay, but of course over here, you might don't want to repeat what you just heard. You want to answer a question. So we can do a Q&A over here. For example, whatever I heard, for example, like I heard, what is your name? Then for over here, I say my name is something, something. Okay, and keep in mind that this example, I make the volume like the very, very small. So sometimes you don't realize it actually responds. So if it is too soft, remember when you run this example, put this thing to 0.5 or something bigger, right? So that you can hear the response. Okay, I put this 0.01 is because like I want to prevent the echo. Because if your robot hear what it say and then it say it out and then you hear what you say again, then it say it out again, then it become a loop, then it become like an echo. So that's why the initial volume become very small. But when you're working on, you can adjust your microphone and speaker, then you can increase this to 0.5 or even 1. If let's say your microphone and speaker is not in the same direction. All right, so this is a very, very simple example to show you how to combine synthesis and recognition together, but you need to work out something on the logic here to compare, right, the input and what the output you're supposed to do. All right, and with that, you can start thinking how to do the assignment today, right? Okay, but before I jump into the assignment, there are a lot of things we can do in speech interaction. For example, like other language support that I show you some example. If using online, you can actually switch the language, and even like just now what Dan showed you, you can mix Chinese and English together, and the iFlyText system still can recognize perfectly. So yeah, a lot of things you can do. Like for our community in Thai, you might want to add in the Thai language support. I believe you can find that. Yeah, if any of you got any nice example, feel free to share with us so that I can share with the community. Okay, then we also have this what we call the sound detection and localization. This is something that I didn't have any example here, but this one requires some additional hardware. For example, you want the effect like the Google Home that the device or the robot can recognize the direction where the sound comes from, or where you actually call the robot, so that the robot can actually turn and find the sound source and so on. So this is also one very nice features to have, especially for example, you have a mobile robot, you design your service robot to be moving, for example, in a hall. Then when someone actually calling the robot, then the robot will know where the sound comes from. So you can use this technology to detect the direction of the sound. Then something more complicated, speech understanding and dialogue manager and dialogue system. Okay, so this one is, yeah, eventually like it connect to, for example, NLP, natural language processing and so on. So you start to understand the content. Okay, you want to understand the content, and then based on different question, what the robot's supposed to say. And also the robot also might want to consider the context. For example, when you say hello to the robot, then the robot might say good morning or good afternoon or good night. It depends on the time. Okay, that's the context. So this is something that you can make your robot very intelligent if you can design very high this dialogue system for the robots. Okay, so a lot more things, and dialogue system and dialogue manager, this one by itself is actually a very big development by itself. So what we have done today is just the very basic synthesis part and also the recognition part. So you can see like in this loop, we actually have a lot more things that we can do to create a very nice interactive service robot. Okay, So with that, the assignment for today, just for your practice or exercise, you combine the synthesis and also the recognition together. You can use offline or online method, it doesn't matter, okay? You can refer to the TalkBack example to show you like how I put things together. To develop a robot speech question and answer system. Question and answer system means you have a list of question and answer, then you give to the robots. Then every time when someone asks certain question, then the robot will refer to the list and give the appropriate question. Yeah, so I think this system is very useful for a lot of application. Whether, for example, you want to build a receptionist robot, then, for example, like in front of the hotel, then the robot will always say some frequently asked question. Like you go to the hotel, you ask like, do you have any room? What kind of room you have? What is the rate? I want to check in and so on. So yeah, this is one of the things. Or you can develop a robot for retail, for example, a shop. Then you have the introduction of your product as a question and answer list in the database. So every time with the guest or the customer asks some, for example, like, what is the advantage of this product? How much is this? And so on. Then, yeah, you have the database ready. Then the robot able to answer the question based on the question and answer database that you provide. Yeah. So try to work on this example. I think will be very interesting. Okay, right. So with that, I have completed the content for today. So before I close the system, I would like to open for question and answer. So can I invite my local committee to help me conclude what I just said just now, and also to ask if anyone want to ask question. Yeah, you can ask in Thai.
ใช่ครับก็อย่างที่เขาบอกไปเนาะก็คือในส่วนที่เป็นส่วนนี้เนี่ยก็จะเป็นในส่วนของ speed recognition นะก็คือแบ่งออกเป็นทั้งออฟไลน์แล้วก็ออนไลน์ก็อย่างที่เขาแนะนำนะครับก็ตัวออนไลน์เนี่ยอาจจะได้ความสามารถที่มากกว่าได้เปอร์เซ็นต์ความถูกต้องที่สูงกว่าแต่ว่าก็แลกกับการที่เราต้องเสียเวลากับการที่เราจะยิงข้อมูลไปหาเซิร์ฟเวอร์บ่อยๆนะครับก็ต้องลองชั่งน้ำหนักดูว่าเราจะใช้อะไรทำอะไรเนาะส่วนในส่วนที่เป็นSpeed Interaction Class เนี่ยก็มีอีกมากมายอย่างที่เขาบอกนะก็สามารถไปหาทดลองได้นะครับโดยที่เขามี assignment เนาะก็คือให้เอาในส่วนของ Speed Synthesis กับ Speed Recognition เนี่ยมารวมกันนะครับเป็นTalkBack Example ก็แบบ TalkBack Example นะโดยที่เขาก็ให้เราลองดีไซน์ในส่วนของ Question and Answer เช่นที่เป็นการทำแนะนำ Product แนะนำสินค้าหรือว่าเป็นการสอบถามรายละเอียดต่างๆเนี่ยก็สามารถที่จะทำได้เนาะแล้วก็เป็น assignment ที่เอาไปอยากให้ทุกท่านได้ทำกันนะครับแล้วก็สุดท้ายเนี่ยก็คือก็ทำเหมือนเดิมครับก็อัปโหลดทั้งหมดขึ้น GitHub เนาะก็คือได้ฝึกใช้ในส่วนของGitHub แล้วก็ท่านจะได้เก็บโค้ดตัวนี้ไว้เป็น on cloud เนาะก็คือสามารถที่จะมาเปิดอ่านในอนาคตได้ง่ายขึ้นแล้วก็สามารถแบ่ง sharing กับคนอื่นได้ง่ายด้วยนะครับแล้วก็ตอนนี้เปิดในส่วนของเซสชันที่เป็น Q&A session นะครับก็สามารถสอบถามได้เลยครับ It's okay, Jeffrey.
All right. Okay. So question and answer. All right. So yeah, Q&A. So anyone would like to ask any question? Can you do the assignment, or do you have any difficulty to do the assignment or do the exercise for today? Can you follow? Yeah, I would like to know some feedback from the audience because today is the first time that we introduce the function. So I really hope like you can learn something and yeah, use this for your development. So yeah, next week we are going to switch to another topic, which is the vision system. So I hope today you have learned some basic on the speech interaction, and yeah, you can start develop your robots. So yes, Lee.
Okay, hi.
Hello.
So actually I wanted to ask a question is regarding last week's assignment.
Okay.
So I encountered an issue on the cat kin make command where it says that it cannot find the package of the dynamic mixer controllers.
Yep.
So when I try the command, the sudo apt-get install command, then it also stated that it could not locate the package.
Yep.
So I'm stuck at there.
Okay, I understand.
Yeah.
So I think this is a common question, and I think last week the slide I didn't update because like written down there is actually if you install the dynamic mixer controller and dynamic mixer motor package, it should work. Okay, but apparently that is the solution for kinetic version. Okay, and then I test it out. For melodic, we actually no longer have that. How to say? The dependency in the depths repository. So I would suggest that anyone that faced that problem, please remove this ARM folder. Okay, you can delete the whole ARM folder and it should work. Okay, because in this classroom, online classroom, we are not going to show you any ARM movement because you don't even have the ARM. So yeah, you can safely delete this folder. Okay, so I hope you can understand here. So you can open up and then you just delete this whole folder, the ARM folder. We are not going to use that. Okay, so once you delete this whole folder, you should be able to compile.
Okay, understood. Thank you. Thank you so much.
Yep. Yes. Yeah, next question. Someone from Thai. Yeah, you can ask in Thai, no problem. Yeah, feel free to ask. Anyone? So just now I saw that someone raised their hand. After Lee, saw another name. Yes. Okay. Yes, you can ask question.
Can I ask in Thai?
Yes. Please.
ก็คือผมลองทดสอบ Google Server ครับที่เป็นแบบออนไลน์เนี่ยมันขึ้นว่า unable to register with master node ครับ
เดี๋ยวผมลองถามเขาดูให้นะครับJeffrey
Yes.
he asked that he used the Google API and then it's returned the master node is not registered.
Sorry, again. Master node is
not registered. I think
is
ใช่ไหมครับ
unable to register with master node.
Oh, okay. So which mean your ROS master is not there? Is that correct?
Oh, okay.
Have you run ROS call?
Yes, already run.
Okay, or if you currently running, can you show us your screen? Is that possible?
Okay, let I try.
Yeah, you can show us your screen. So yeah, and that will better. Yeah, I stopped my sharing, so you can share your screen. Okay, yep. Unable to register the master node. Okay, so you are using the virtual box and unable to register the master node. Okay. I think something with your network setting. Okay, for your virtual box. Is your virtual box how to say, what kind of network protocol? Are you using the NAT?
NAT, no. I use bridge.
Okay, bridge. Okay, maybe that is the problem because like it might not able to find the local host.
Oh, okay.
Yeah, so you might want to look at so yeah, this is something I also not very sure because I don't know how you set up your network for your virtual box because sometimes you might want to connect and I suspect this is the ROS actually not so sure where is your local host, so that's why you cannot connect or you cannot find the ROS master.
Okay.
So maybe you want to look more detail on the network part.
Okay.
Maybe you want to cut everything and you just put NAT. The protocol should be the most straightforward one. Yeah. But I think this one you need to restart if I'm not mistaken.
Okay, I think so. I need to restart
your virtual box. Yes.
Okay.
So what I can say is like you want to check your network setting.
Okay, thank you.
But working with VirtualBox, you have all this kind of question, all this kind of problem, which is so you need to learn how to debug. But the hints that I can give you or something that I can guess is the network problem.
Okay, thank you.
Right, welcome. Okay, any more question? Yeah, any other question? Feel free to ask. Anything that you can share or anything that you want to comment about today's content? Anything you want to ask or anything anything you want to share? No problem. Yeah. Okay. Some.
ขอถามเป็นภาษาไทยครับ
Yeah, you can ask in Thai. No problem, right?
สำหรับไอตัว assignment นะครับมี deadline ไหมครับแล้วก็ต้องส่งยังไงครับหมายถึงว่าพอเราอัพเข้า GitHub ของเราแล้วเนี่ยเราเก็บไว้เฉยๆใช่ไหมครับ
Jeffrey, he asked for the about the assignment. He want to know that the assignment has have any deadline or how to submit the assignment to you.
Okay, I'm not going to give you any grade. Okay, you don't need to submit to me. But if you face any problem with your assignment, we can discuss. Okay, you can do it anytime and we can discuss. The assignment or the exercise is for you to practice on the content that I deliver. So if you do the assignment, then you will exercise the example that I show, and then you might be able to eventually master everything and integrate and build your robots. So that is the purpose of the assignment. So you don't need to submit to me, and there's no deadline. You can do it anytime you like. It is just to help you to practice on the class. But of course, if you, for example, like you have done your assignment and then you upload to GitHub, then you have question to ask, yes, feel free. And yeah, anything that you upload on GitHub is easier to share and I can view, and that is easier for us to discuss. Yeah.
Thank you so much ขอบคุณครับ
Right, welcome. Any more questions?
Hello,
yes.
Do you record this class?
Yes, I record all the
and
class.
Where can I see the recording?
Okay, I need some time to process, and then I have class every day, so I need some time. So usually what I can promise is next week you will see the recording for this week, because this week you can see the recording from last week. Okay.
Okay, and the recording link is posted in the Line group.
If you go to the Robot for All courseware, where you look the slide, the video is there. If you go to right, so let me show you where's the video. Okay, so if you go to this one over here, if you go to last week class, the video is there here, right? This is the video, and for the ROS basic, okay, and we have upgraded the server. Now should be quite stable. Okay, so far today it don't give me the error anymore. So I hope the server can serve you better now. And yes, the video will be here, right?
Okay, thank you.
Right, so next week I will add it over here, right? So you can find the video and the slide together. Okay, but give me some time, okay? I have a lot of things to process, so you will find the video like 1 week before, right? Or 1 week after, sorry. 1 week after, then you'll find the video. Okay, right, any more question? Yeah, so this is the video for the ROS basic last week. And you can find the video for all other classes as well. So if you come to OP and you want to learn about SP, you can find the video for tomorrow as well. So everything is available over here, right? It is in your in the course material. Question? Any more question? Question from the floor? Anyone? Any question?
ขอสอบถามเรื่องช่องทางการสื่อสารนะครับว่าในห้องเรียนนี้มีกรุ๊ปไลน์อะไรไหมครับ
Jeffrey, he wants to know that how to communicate with another another people in this group by the Line group, or they have some conversation channel?
Sorry, how many what?
We have we have some communication community or
communication, right? Okay.
Group.
Okay, so so if you come, okay, so the most easiest way for you to get me is you can come to this one, class group, right? So I guess nobody use this, but yeah, I think this is the best way for us to communicate. Oh, sorry, I'm not in this group yet. Okay, right. So over here, there's a forum. Yeah, feel free to type your question here. Okay, we can communicate here. But of course, if you add me in Facebook, yes, yeah, you can talk to me in Facebook. But if you want to discuss anything technical, I think this forum will be a better place for us to discuss. But of course, if you want anything, you can write email. Okay, the email, yes, you can get the email. But it might be a bit slow. Okay, so it's either this one, or you can come to you can come to our the email. Okay, the email is over here. This is the email. So this is the email. Just now the class group in the forum for more lengthy discussion. Email if you have anything you want to ask regarding the competition, for example. Or yes, you can add me in Facebook. Yes, I'm over there as well. But I will prefer you to discuss in class group because anything that we discuss will be shared for everyone. Okay, so it depends on what type of question. I'm not sure what type of question you want to contact me, but these are the things that, yes, you can get me. Okay.
Excuse me.
Yep.
I cannot access to the forum.
Because you need to request.
Yeah.
You need to request first. Okay, later I will add you all in. Okay, don't worry. Anyone that requests, you will get in. Okay.
Yes,
so currently
I already clicked the request.
Okay. Give me some time, because if you just request, then give me some time to respond. Okay.
Thank you very much.
Yeah, welcome. Any more question? Any question? Okay, so the time is already like past 9:30, it's almost 45. So I'm very glad that today we discussed a lot, and also you ask question actively. I'm very I appreciate. So I hope we can continue this for the coming 3 more weeks. And also I really hope like this will be beneficial for you to actually learn some technique that you can use it for the competition and also for your studies, for your projects, and so on. Okay, so once again, I would like to thank Jupyter Robot to show the demo today, and also our Thai local committee member to help me on the Thai language support. And thanks all of you to turn up today. We have like over 50 plus today, so it's very happy for this big crowd. And also I appreciate your question, and I will try my best to answer all your questions. And I think now our system, everything is almost stable to provide you the materials and also the videos and so on. I hope all these resources will help you for your development. Right. So thanks a lot, and I will see you next week. If you have no more questions, yes. Right. So if you want to ask anything in private, you can ask after this. Okay, so we will stop the recording, and we can still I will still be here, so you can ask anything in private later on. Okay, right. So thanks a lot, and we will see you next week. Okay, see you. Bye bye.
Goodbye. Thank you so much.